Hi, this is Mrs. Allen, and in this video we will be discussing the 68, 95, and 99.7 rule. Normal models give us an idea of how extreme a value is by telling us how likely it is to find one that far from the mean. For a normal distribution with a mean mu and a standard deviation sigma, 68% of the values fall within one standard deviation of the mean. 95% of the values fall within two standard deviations of the mean, and 99.7% of the values fall within three standard deviations of the mean. So let's look at a bell-shaped curve to help explain this. It turns out that in a normal model, about 68% of the values fall within one standard deviation of the mean. So if we start here in the middle with the mean and go out one standard deviation in both ways, we will see the yellow area. 68% of the values will fall within that area. About 95% of the values fall within two standard deviations of the mean. So again, starting at the mean and going out two standard deviations in both directions, we see the green and yellow portions colored on the graph give us 95% of the values. And about 99.7%, almost all of the values, fall within three standard deviations of the mean. So starting again with the mean and going out three standard deviations both ways, we get almost all of the values, 99.7%. So looking at this graph, it's a little simpler. Reaching out 1, 2, and 3 standard deviations on a normal model gives us the 68, 95, and 99.7 rule. So let's look at an example that uses this rule. The SAT reasoning test has 3 parts: writing, math, and critical reading. Each part has a distribution that is roughly unimodal and symmetric and is designed to have an overall mean of about 500 and a standard deviation of 100 for all test takers. In any one year, the mean and standard deviation may differ from these target values by a small amount, but they are a good overall approximation. Suppose you earn a 600 on one part of your SAT. Where do you stand among all students who took that test? Well, I want to see how my SAT score compares with the scores of all other students. To do that, I'll need to model the distribution. I will model the SAT score with a normal model, 500, 100. That means we have a mean of 500 and a standard deviation of 100. So the first thing I want to do is draw my bell-shaped curve with the 68, 95, 99.7% rule. So our mean was 500, so I will change the mean to 500. Then our standard deviation is 100, so I will add 100 to 500 and subtract 100 from 500 to get 4 and 600. Now I will go out two standard deviations in both directions, getting 300 and 700. And then I will go out three standard deviations in both directions, getting 200 and 800. My score of 600 is one standard deviation above the mean. That corresponds to one of the points of the 68, 95, 99% rule. About 68% of those who took the test had scores that fell no more than one standard deviation from the mean. So 100 minus 68% gives us 32% of all students had scores more than one standard deviation away. Only half of those were on the high end, so about 16%, half of the 32% of the test scores were better than mine. My score of 600 is higher than about 84% of all scores on this test. Okay, now let's try one on your own. Suppose it takes 20 minutes on average to drive to school, with a standard deviation of 2 minutes. Suppose a normal model is appropriate for this distribution of driving times. Pause the video and try to answer this question. When you have completed it, restart the video and check your answers. Okay, so our mean was 20 minutes with a standard deviation of 2 minutes. So I'm going to draw my bell-shaped curve and label it correctly, starting with my mean of 20 minutes and going out 1 standard deviation, adding 2 minutes and subtracting 2 minutes, and so on. 24 minutes is 2 standard deviations above the mean, right here. Because of the 95% rule, we know that 2.5 of the times will be more than 24 minutes. So 2.5% of the time, it will take you more than 24 minutes to get to school. Thank you for watching this video on the 68, 95, and 99.7% rule. Hopefully it helped you understand it a little better. Thanks.